Hello, my name is Nick, and this section is all about functions. Now, in this lesson, we're going to learn what is a function, and yeah, that's pretty much what we're going to learn. So, to start out, let's make two sets. A set is any collection of things, and we're going to call this first set X and the second set Y. Now, our set X is going to be a set of chairs. So, we got chair 1, chair 2, chair 3, chair 4, let's say chair 5 over here. And in our set Y, we're going to have a set of tables. So this is table 1, table 2, table 3, and table 4. Now, what we're going to do is we're going to send the chairs to the tables. In other words, we're going to make a rule which says which chairs go to which table. And our rule is going to be called little y. Notice that this y is little y, and this y is big Y. Big difference. Little y is the name for the rule that sends the chairs to the tables. Big Y is the set of tables. Okay, so little y, let's say little y takes the first chair to the first table, because that sounds kind of reasonable. And let's also send the second chair to the first table. Now let's send the third chair to the second table, fourth chair to the third table, and fifth chair to the fourth table. Okay, I think that's a nice rule. This one here, this table here, we can seat two people, and the rest of these three tables, one person sitting by themselves. Okay, so that's our rule, and the rule is called y, and this is an example of a function. So actually, all a function does is take a set of inputs, I use a different color, a set of inputs, x, and then it has a rule which sends them to a set of outputs, y. And the most important thing about it is that for each one input in x, there's only one output that it gets sent to. So for each of the one inputs, it gets sent to only one output. Now I know that this output here has two inputs sent to it, and that's okay, because even though there are two inputs, 1, 2, going to the same output, we still have that for each one input, it only gets sent to one output. So that's an important thing. Even though one output has two inputs sent to it, each of our inputs only gets sent to one output. We don't have this input sent to this output as well, for an example. That's not allowed. Otherwise, it's not a function anymore. Okay, another way to visualize functions, and this is my favorite way, I like to think of the function as some kind of box. So this is our y box, our function box. And what the box does is, so we got a set of inputs, x, still. So this is our set of inputs. And let's say that this is one of the inputs. And then we've still got a set of y outputs. And what the function does is it takes the input little x, it puts it into the function box, and then out of the function box comes the output y of x. And there's only one thing that comes out of the box. If it comes out to something else, then it's no longer a function, so that's not allowed. There's only one thing that comes out. So this is a function. The function is y. It takes the input little x and it spits out the output y of x. And usually it does something to the input. So y of x is quite often different to x. Okay, let's do another example. So since this is math, most of our functions are going to be actually involving numbers. The reason I did the chairs one is just to make it clear that actually the definition of functions, all you need is a set of things. But most of our functions, our set of things, our set of inputs are going to be numbers, so that's fine. Okay, so our set of inputs in this example, x, let's say we have the inputs, I don't even need to do dots now, 1, 2, 3, and 4. These are our inputs. And then we have a set of outputs, y. And y is going to be 2, 3, 4, and 5. And what our function y is going to do, so we're going to use our function y to send these things together. What our function y is going to do is it's going to take the input 1 and it's going to send it to 2. It's going to take the input 2, it's going to send it to 3. It's going to take the input 3 and you guessed it, send it to 5. I bet you thought it was going to 4, didn't you? And we're going to take the input 4 and we're going to send it to 4. Is this thing a function? Yes, it is. It has a set of inputs, it has a set of outputs, and for each of our 1 inputs, there's only 1 output that it's sent to. We don't have 3 being sent to, say, 2 as well. If it was, then this thing wouldn't be a function anymore. I cannot stress enough how important it is. Each 1 input only goes to 1 output. And it's okay if more than 1 input goes to the same output, as long as we don't have 1 input going to more than 1 output. Hopefully you know the difference between that. Have a think about it if it sounds kind of confusing to me when I'm saying it in my head, actually. Okay, so this is our function y. That's an example of one. Let's do another one. So we're going to have a set of inputs x again. In fact, it's going to be the same set of inputs. It's going to be 1, 2, 3, 4, and our set of outputs is going to be the same. Set of outputs y is going to be 2, 3, 4, and 5. And what our function y is going to do this time is actually what we expected it to do last time, probably. It's going to send 1 to 2, it's going to send 2 to 3, and it's going to send 3 to 4, and it's going to send 4 to 5. So that's little y, taking each of these inputs and sending them to the outputs. Let me write inputs and outputs again. Oh, by the way, another name for inputs is actually domain. So this set x is actually the domain of the function, and another way to write that is inputs. And another name for y, the set of outputs, is actually the range. So this set here is actually the range / outputs. Now, there's something kind of interesting about this. There's something kind of, well, maybe you saw this, maybe you didn't, I don't know, but there's actually kind of a rule. So, let's do an example. When we take 1 and we put it into our function, the thing that comes out is 1 more than 1, it's 2. Similarly, when we take 2 and put it into our function y, the thing that comes out is 3. So another way to write this is 2 is equal to y of 1. By the way, those brackets, you can think of these brackets as we're putting the input x into the function y. So we're putting 1 into y, and 2 is the thing that comes out. So 2 is equal to y of 1. Similarly, 3 is equal to, oops, wrong color. 3 is equal to y of 2. Well, notice that y of 1 is equal to 1 more than 1. Y of 1 is equal to 1 plus 1, which is equal to 2. And also y of 2 is equal to 2 plus 1, which is equal to 3. And actually, in general, it doesn't matter which input we choose. So we usually call our inputs little x. So little x means one individual input, and big X is the entire set of inputs. So in general, when we put little x into our function y, the thing that comes out is x plus 1. The thing that comes out is x plus 1. So there's a rule associated with this function. The rule is y of x equals x plus 1. And in words, that means y takes in the input little x and it spits out 1 more than that input. It increases it by 1. Okay, let's do another example of a function. Maybe this one will have a rule, maybe it won't, I don't know. Actually, no, this one won't have a rule. So let's, again, we'll stick with 1, 2, 3, 4 as our set of inputs. And we'll have, oops, no dot there. 2, 3, 4, 5 as our set of outputs. and little y is going to send 1 to 2, it's going to send 2 to 2, it's going to send 3 to 3, and it's going to send 4 to 4. Now, question, is this thing still a function? Is this thing still a function? The answer is yes, it is. But what about this thing here? There's a problem because we've got this output 2, which has 2 inputs sent to it. Nick, I thought you said that only that each input can only be sent to one output. Well, I did, and it's still true here. For each of these 1 inputs, there's only 1 output that comes out. So the input number 1 gets sent to the output number 2. That's only 1 output. Similarly, the input number 2 gets sent to the output number 2. Again, that's only 1 output for each input, even though they both get sent to the same output. So that's fine. Don't worry about that. What we should be worried about is something like this. 1, 2, 3, 4. I love this domain so much. 1, 2, 3, 4. It's so simple and easy. It's only got 4 objects. So nice to write. Y, again, we'll do 2, 3, 4, 5. And our function y, our object y this time, is going to take 1 to 2. It's going to take 1 to 3. And it's going to take 3 to 4. And it's going to take, you know what? It's going to take, no, I'll take 4 to 5. Why not? Is this thing still a function? The answer is no. The answer is no, it's not. There are 2 problems. The first problem, well, there's only one problem actually. It's this input number 1. Problem with number 1, this 1 input is being sent to 2 outputs. And that can't work for a function. For a function, we said each 1 input should only get sent to 1 output. Well, here we have 1 input getting sent to 2 outputs. So this thing is not a function. What should we call it? What should we call this thing? Well, let's call it a mapping. So it is still a mapping from one set, use a different color, same color again, still a mapping from one set to another set. It still maps the set X to the set Y, but it doesn't do it in such a way that for each 1 input there's only 1 output. So we can only say that Y is a mapping. All functions are mappings, by the way. They still map the set X to the set Y, but they do it in such a way that makes them functions. For each 1 input, only 1 output comes out. Can we see a rule for this mapping? I don't know. I can't see a rule. I don't really think there's a general rule that we could write about this. Also, there's another problem. This 2. So I said that Y maps the set X to the set Y. It actually doesn't, because it doesn't send 2 anywhere. It doesn't send the input 2 anywhere. So actually, let's make a new set. We'll call it Z. And Z is the set 1, 3, and 4. Then we'll say Y is actually a mapping from Z to Y, because it doesn't send this element here, this number 2 in the set X. It doesn't send that one anywhere. So Y is a mapping from the set Z, which consists of 1, 3, and 4, to the set Y, which consists of 2, 3, 4, and 5. But it is not a function because it takes the input number 1 and sends it to 2 outputs. If you wanted to go the other way, and say Y actually goes from Y to X, then it could be a function, because it would send this number 2 to 1, it would send 3 to 1, it would send 4 to 3, and it would send 5 to 4. In that case, and let's just call this like Y inverse, so we're going backwards this time. In this case, it is a function, because each input is only sent to 1 output. So again, you have to be careful about the way you think about these kinds of things. If your set of inputs, if for each input in your set of inputs, the mapping takes this 1 input and sends it to only 1 output, then it's a function. If it does not do that, it is not a function. And I think I've said that enough times. Hopefully it's clear. Thank you very much for watching. Check out the notes that go with this section, and see you guys next time. Take care. Bye.